Okay, today in this video we're going to talk about a new way of graphing coordinates, and it is called polar coordinates. And just to review, so far we have learned rectangular coordinates, and those are simply coordinates that we've been used to doing for a very long time. An example would be, let's say I gave you the coordinates 3, -4. We would go right 3 and down 4. And we would put a point. And maybe an example of an equation would be y is equal to 4, oops, that's no good, 4x minus 7. So that would be some linear function. And then in the last couple of videos, we've been talking about parametric equations. And so this is when we now have introduced a third variable to you called t. And maybe we have some equations like 2t minus 4 is equal to x, and maybe y is 4t squared plus 7. And you have to plug various values of time in here to get the position. Now today we're going to be talking about something called polar coordinates, and the r represents the distance away from the origin. The distance away from the origin. And the theta represents the angle that you go towards. The angle you go towards. That's about as simple as we can make it. So let's see a few examples in this next slide. Let's say we have 3 points that we have given to us, P, Q, and R, and we want to plot those points in polar coordinates. So first we need to remember that polar coordinates are r and theta. And this one is, once again, r and theta. And this one is r and theta. Let's see if we can plot all 3 of these. The r is the distance away from the origin, so that's going to be 2 units in the direction of pi over 3. Pi over 3 is 60 degrees. So if you look, we've got a little unit circle here. And so if this is our origin here at 0, 0, we want to go 2 units in the direction of 60, and we want to put a point. And so there is, we'll call that point P. All right, and we now want to do point Q. Point Q, now notice it has a -1. That means go in the opposite direction. So anytime the radius is negative, that means you're going to be going in the opposite direction of this angle. 3 pi over 4 is 135 degrees. That is over here. But we don't want to go towards 135. We want to go in the opposite direction 1 unit. So that's going to put us right here at 1 unit in the opposite direction of 135. So we will call that point Q. Now we want to do point R. And this says go 3 units in the direction of -45. Now, the -45 just simply tells you to rotate clockwise 45 degrees as opposed to counterclockwise. We've talked about that before. So it doesn't have an effect on which direction you go, but it's 45 degrees rotated backwards from 360. So you could also say this would be the same as 315 degrees. So we are going to go 3 units towards 315. So 1, 2, 3, and that is point R. Now a lot of times you will have to describe these points using 2 different pairs of polar coordinates. So 2 units in the direction of 60 degrees is the same as going 2 units, let me do it in yellow, 2 units in the opposite direction of 240 degrees. See if that makes sense to you. 240 is here. Instead of going 2 units towards 240, we're going 2 units away from 240, which is the same as going 2 units towards 60. So I want you guys to actually try, pause the video and see if you can come up with another set of polar coordinates for Q and for R. All right, for Q, we have this point right here. And so notice that that is the same as going 1 unit towards 315. So this same point Q could be described as 1 unit towards 315. And now we will do the R. Well, 3 units towards 315 is the same as 3 units in the opposite direction of what angle? In the angle in the second quadrant, 135. So these are different ways to describe the same point. Let's say we are given an ordered pair in rectangular form, or we're given an ordered pair in polar coordinates, and we want to convert back and forth between rectangular coordinates and polar coordinates. Well, there are some conversions that we can use, and that's what we're going to talk about here. So let's just say that we have an XY axis, and let's just say we have some point out here, and we'll call that point XY. So that means that we will have a distance from the origin to that point, and we will call that distance R. Instead of calling it magnitude, instead of calling it the hypotenuse, we're now going to call it the letter R, which represents, as we said in the last slide, the distance from the origin to a specific point. And so now we can go over here, and then we'll go up here, and now we can say that this distance must be X, and that distance must be Y. Nothing different than we've done before. So if we do the Pythagorean theorem, we will say x squared plus y squared equals r squared. So now when we're converting back and forth from rectangular coordinates to polar coordinates, or vice versa, every time we see an r squared, which is, let's just remind ourselves, anything with an r is polar, we can now replace r squared with x squared plus y squared, and anywhere we see x's and y's, that's rectangular coordinates. So now we can go back and forth. Now we can also use our knowledge of trig, and let's say that angle is theta. So we can say cosine of theta is equal to my adjacent over my hypotenuse. So if I multiply both sides by r, this is no different than what we did with the vectors. We see that x is going to be equal to r cosine theta. And if we do the same exercise, we'll get y equals r sine of theta. So now, if we are in rectangular mode, every time we see an x, we can replace it with r cosine theta. And every time we see a y, we can replace that with r sine theta. And that's where all of these formulas are coming into play here. And so we're going to see how they are used on some sample problems. Okay, we are given a point P, and it is in polar coordinates. We know that because we can see that the first number is an r value, and the giveaway is that the second number is an angle theta. And that's how we know that these are polar coordinates, not rectangular. And we want to convert them into rectangular coordinates. So we just use our formulas here. So our x is r cosine theta, and our y is r sine theta. Now, just for confirmation, let's just make sure that we know where this point is. And so we see that we are going 3 units in the direction of 5 pi over 6. 5 pi over 6 is 150. We're going 3 units in the direction of 150. So that will be somewhere over in this direction right here. All right, so let's see how we're doing here. If we use our coordinates, our conversions rather, we will say r, which is 3, and cosine of, well, I'm just going to put 150 degrees, and then the y is going to be 3 sine of 150. And we may remember that the cosine of 150 is negative root 3 over 2. So that's going to be negative 3 root 3 over 2. And the sine of 150 is simply going to be 1/2. So that's going to be 3 over 2. And we see that that looks pretty consistent. We're going left a certain amount, that's your x, and you're going up a certain amount. All right, let's see if we can do letter B. Here we're going to need a calculator because negative 200 is not one of the unit circle angles that we have memorized. But let's just see if we can figure out exactly where this angle is. So we'll draw a little XY axis. And this is 2 units in the direction of negative 200 degrees. So we're going to rotate negative 200 degrees. That's negative 180. And there we go. So 2 units in that direction is going to be similar to where we were in the last problem. All right, so that's where we want to make sure that we end up when we convert to polar coordinates. So let's see what we get. X is equal to 2 cosine of negative 200. Is it okay to use 160 here? Sure, because negative 200 is the same as positive 160. Not a problem. So y is equal to 2 sine of negative 200 degrees. And so when we plug those into our calculator, we get negative 1.87. Make sure your calculator is in degrees. And we get a 0.68 number for y. And that's how you convert from polar coordinates to rectangular. All right, now in example 4, we want to go backwards, and now we are given a point P in rectangular coordinates. So let's see if we can figure out where that is. Well, it's going to be negative 1, 1. So therefore, we need to go left 1 unit and up 1 unit. And there is the point. And so if we draw a triangle in that quadrant, go there, there, and there. So now we are going to label our triangle. So that'll be negative 1 that side, and that's 1. And remember that polar coordinates are r theta. R is the hypotenuse, it's the magnitude, it is the distance away from the origin. So we need to find the hypotenuse. Well, we're going to do that by Pythagorean theorem. So that's going to be negative 1 squared and 1 squared. That's going to be root 2. And so our r is root 2. And we recognize we don't need a calculator because we recognize this to be a 45, 45, 90 triangle. So this little angle right there is going to be 45. That makes the angle from standard position to be 135. So you can't use 45 because that's not in the second quadrant. So root 2 comma 135. Now notice it says find 2 polar coordinate pairs for the points with the given rectangular coordinates. So this goes back to something we talked about before. We can describe this point, we'll call it point P, as either root 2 towards 135 or root 2 away from the angle that's in the fourth quadrant that's directly across from it, and that's going to be 315. By the way, a really easy way to do that is to just add 180 to the angle. If you add 180 to 135, you will get 315 degrees. And so that's how you know what the angle you're opposite from. All right, so now let's go on to this next example here. And now we have the point negative 3, 0. All right, so now we are going to go left 3 units and put a point. And that's going to be point Q. So it's pretty simple to figure out what the distance away from the origin here is. It's just simply 3. And so our r is 3. Remember, it has to be r comma theta. Theta is the direction that we're going towards. Well, we're going towards 180. So there you have it. Now, how else could we describe this point Q? Well, we could describe this point Q as 3 units in the opposite direction of what angle? 0 degrees on the unit circle. So there is your answer. All right, example 5, we want to now work on converting from a polar equation into a rectangular equation. So we're not converting ordered pairs, we're actually converting the entire equation from one coordinate system to another. And so let's just start here. We have r equals 4 secant theta. So let's just keep in mind what we're trying to do. We are trying to take something that has r's and thetas and convert it to something that has x's and y's, because that is rectangular and this is polar. So we remember from our trig unit that secant of theta is the same as 1 over cosine of theta. And if we multiply both sides by cosine of theta to get rid of the denominator, these are going to cancel out nicely there. And then we end up having r cosine theta equals 4. Then we remember that r cosine theta up here is equal to x. That's how we convert it from r's and thetas to x's and y's. In this case, it only has an x, so x equals 4. Now we may remember that x equals 4 is just a vertical line at 4. And so this is what that would look like in rectangular. And if you were to type r equals 4 secant of theta into your calculator, and make sure your calculator is now not in rectangular mode, not in parametric mode, but now in polar mode, you'll see that you'll get a vertical line on your screen. Okay, so now we need to go to this next example here. And it says r equals 4 cosine of theta. Now the method you want to do here is a little tricky. What you want to do is you actually want to multiply both sides by r. So let's go ahead and do that. So we multiply by r here and multiply by r there. So we end up getting r squared equals 4r cosine of theta. Now r squared, according to this formula, is equal to x squared plus y squared. That's how we get rid of the r squared, and we go from polar to rectangular. And then r cosine of theta, as we saw in the last problem, is equal to x. So this is equal to 4x. Now we need to do a little bit of completing the square. We know that you guys don't like that, but it's really not that bad. So what we're going to do is we are going to take half of the middle term. So half of negative 4 is negative 2. And you want to square that. That's going to give you plus 4. Now you can't just add plus 4 to this side without adding it to the other side. So you're balancing your equation out. And then when you do that, you'll be able to factor this trinomial right there. And so that's going to factor into x minus 2 times x minus 2, which I can write as x minus 2 squared. And this is y squared. And this is just 4. And then we remember maybe from another video that the formula for a circle, let's write it down here, is x minus h squared plus y minus k squared equals r squared. So now we can identify what the center is. This is going to be a circle with a center of 2, 0, and a radius of 2, because this is r squared and r squared is 4. Take a wild guess what we want to do now. We want to go backwards. We want to convert now from rectangular form, and maybe we'll put up here, that means x's and y's, to polar form, which is r's and thetas. So we want to go backwards. So we want to get rid of all these x's and y's and convert to r's and thetas. So that means we're going to have to do some foiling here. So x minus 3 times x minus 3. Please don't make the cardinal sin of squaring the x and squaring the 3. You've got to FOIL it out. So that's going to be x squared minus 6x plus 9. And then the same thing here, y minus 2 times y minus 2. So that's going to be plus y squared minus 4y plus 4. It looks like a 9. There we go. Plus 4 equals 13. All right, so we're going to do some grouping. We're going to group the x squared and y squared together. X squared plus y squared. And we're going to group the, let's do it in another color. We'll group the 9 and the 4 together. And that's going to be 13. And we also have this negative 6x and a negative 4y plus 13 equals 13. And we can see that the 13s, if I subtract them, it's going to cancel out. And that's always going to work out that way. And so the constant term is going to cancel out. Now we see that x squared plus y squared, maybe we'll underline that, that is equal to r squared. So that's how we get out of rectangular into polar. So r squared, our x is r cosine of theta, so minus 6r cosine of theta. Our y is r sine theta, so minus 4r sine of theta. And that's equal to 0. Now all terms have a common r value. So we can factor that out. So that's going to give us an r on the outside, and then an r minus 6 cosine of theta minus 4 sine of theta equals 0. And just like anything else, we're going to set both of these equal to 0. So let's go ahead and do that. So r equals 0. Well, if you have, that's just basically a point. R equals 0, there's no radius. But this one, we have r minus 6 cosine of theta minus 4 sine of theta equals 0. We solve this for r by moving everything to the other side, and you get 6 cosine of theta plus 4 sine of theta. And this is going to create a circle. We know that because if we go all the way back to the beginning of the problem, this is a formula for a circle that has a center of 3, 2, and a radius of square root of 13. And that's how you convert from rectangular form into polar form. Okay, in this last problem, we have a very simple problem. We've got an airplane that is being described as being 8 units away, or should I say 8 miles away from the origin in a direction of 110 degrees. So that's a polar coordinate. And then we have another airplane that is 5 miles away in the direction of 15. And we would like to see how far apart they are. So we are actually looking for the distance from here all the way to there. So we recognize this to be a triangle that is not a right triangle because the bigger angle here is 110 degrees and this little angle is 15. So that's going to make this angle inside of here, it's going to make that 95 degrees. So 95 degrees is the angle inside of the triangle. So we'll put it like that. So that's going to give us, and we know that this is 8 and this is 5. So that gives us a side angle side triangle. We can use the law of cosines. So when we use law of cosines, we are going to get, we'll just say a squared equals 8 squared plus 5 squared minus 2 times 8 times 5 cosine of 95 degrees. Plug that into your calculator. Make sure you take the square root, and you get A is 9.79 miles, and that represents the distance that the airplanes are apart from each other.